the derivative defined as the limit of this quotient, f of x plus h minus f of x over h. I will first prove the first derivative formula. We will find the derivative of the function f of x equals c, a constant value. So the first thing we will do is calculate f of x plus h. Because f of x is a constant, it always has the output value of c for all input, including the input x plus h. So when I use my limit of that ratio, I will have f of x plus h is c minus f of x, which is c over h, which equals the limit as h approaches 0 of 0 over h. However, this fraction can reduce to 0 because anything 0 divided by any number is itself 0. And the limit of a constant is that constant, which gives me my first derivative, f prime of x equals 0 if f of x equals c. Next one. Using the same derivative formula and technique, I will calculate the derivative of f of x equals 1. With this, we will actually just use the property or the result that f prime of x equals 0 from our proof. Okay. I will now do this by taking the derivative of a line. F of x equals ax plus b. So f of x plus h will equal a times x plus h plus b, which simplifies to ax plus ah plus b. Then I'm going to take the limit as h goes to 0 of f of x plus h minus f of x over h. I will simplify and combine like terms. Ax minus ax, b minus b gives me ah over h, which gives me a. So the derivative of f of x equals ax plus b produces f prime of x equals a. The derivative of a straight line is its slope. The next few I'm going to give you the rules without giving the proof of the rules. And that is our power rule. And I'm going to use a slightly new symbol to represent taking the derivative. This symbol here will be a command statement, which basically means take the derivative of this function. Well, if I take the derivative of this function, I will get f prime of x. So I have a command and the result of the command. The command is to take the derivative of that function. The result is the derivative of that function. So, for instance, going back to our original one, the derivative of a function who equals c is 0. The derivative of a function ax plus b is a. Both of those we proved. Power rule is the derivative of a function that looks like this, ax to the n equals a times n times x raised to the n minus 1, which is the instantaneous rate of change at any value along the function. I will give an example. For instance, if, for instance, I had the function (4x squared) and I asked you to find its derivative, I would calculate it by taking this 2 times the 4, that's my a times n, and then I would end up with a new exponent that was 1 smaller than the old exponent. So 1 smaller than 2 is 1. So the derivative of the power function f of x equals 4x squared is 8x to the first. We're going to examine some more complicated ways I might be able to write a power function. For example, this is a power function. I will rewrite it in power function notation. The first thing I realize is that a radical can be written as a rational exponent. The next thing I will know, if I want it written in the standard power function notation, I'm going to have to bring up x to that exponent. However, when I raise it up, it's going to make my exponent negative. So, negative 4 over the square root of x is exactly the power function negative 4 times x raised to the negative 1/2. I will now find the derivative of this power function. By taking the negative 1/2 times the negative 4, giving me a positive 2, that equals x. I will take this old exponent negative 1/2 and I will subtract 1 from negative 1/2, giving me negative 3/2. If you like, I could put this back in radical form. 2 over x to the 3/2, which is 2 over the square root of x cubed. Make sure you can see that that's a 2. Everyone happy with this? Some basic rules for derivatives. If you take the derivative of a constant times a function, it is equal to the constant times taking the derivative of the function. Biggest point here is the constant flows through. Another important derivative property. If I take the derivative of the sum of two functions, that equals taking the derivative of the first function and then summing it to the derivative of the second function. I will give an example of my sum property. If you have the function f of x equals x squared minus 3x plus 2. I can actually view this function having three separate components. The power function x squared, the power function negative 3x, and the constant 2. According to the rule written directly above it, then, I can take the derivative of each one of those components individually. Meaning, I'm going to write it out the long way one time only. The derivative of this function equals the derivative of x squared minus the derivative of x plus the derivative of 2. F prime of x equals derivative of x squared is 2 times 1. Subtract 1 from the exponent. The derivative of, it's supposed to be 3x? There we go. Minus 3 times the derivative of x, which will be 1, plus 0, or simply 2x minus 3. So each time we do this, we're going to take the derivative piece by piece by piece of anything being added or subtracted. One more derivative. The derivative of the function e to the x is the function e to the x. Everyone happy so far? Okay. Now, one of the most important things is to remember what a derivative tells us. A derivative is the instantaneous rate of change of the function at any given point along the function. It can also be viewed as the slope of the tangent line at any point along the function. It is interpreted by how fast the function is increasing or decreasing in output units per input unit at the instant you are at that input. It's important to have an understanding of what the derivative tells you. So, let's take a classic example and we will find a tangent line. So, given an equation, we're going to find the tangent line of this function at x equals 0. So to find the equation of a tangent line, I need two things. I need a point, and I need a slope. I always need that to find the equation of a line. I need a point, and I need a slope. So how do I get the point? I get the point directly from the function itself. I plug in 0. So now I have my point, 0, 1. Next thing I need to come up with the equation of a line is a slope. Now I want the equation of the tangent line at x equals 0. The tangent line at x equals 0 has the slope that is equal to the instantaneous rate of change of the function at x equals 0. So the slope of the tangent line equals f prime of 0. I need to find f prime. So the first thing I'm going to do is find f prime of x by taking the derivative of my function piece by piece. The derivative of e to the x is the derivative of negative 4x squared. I'm going to multiply the 2 times the negative 4. Subtract 1 from my exponent. It gives me a 1 exponent. This is not the slope of the tangent. This is the derivative. The tangent only exists at x equals 0. So I need to find f prime of 0. If I plug that in here, e to the 0 minus 8 times 0 is, I've got a point, I've got a slope. Y equals my slope, my point is the intercept, which means I can go directly into slope-intercept form. Slope is 1, intercept is 1. That is the equation of my line.